Thanks everybody for coming. My name is Jamie Stark. I look after voice interoperability and networking for Microsoft Link. And it's my pleasure to bring to you your OFC B343, that's just rolls right off the tongue, session here at TechEd on software-defined networking. A overview for unified communications is the extended subtitle that we weren't able to fit in the non-metro style box there that accompanies our title. And what we're going to do, if the clicker does the clicky thing, is this is a really kind of fun session for me because one, this is just a nascent space a little bit, and so we get to talk about some technology that is new and different and kind of compelling. And so we're gonna start off with a little bit of a primer on what software-defined networking is for those of you that aren't steeped in cloud and enterprise kind of networking, latest best practices or latest stuff that's happening in the industry. And then we're gonna look at how this applies specifically to Microsoft Link and how we think about Link and putting packets down onto the wire with a level of efficiency. And then from there, one of the other reasons why this is fun is I don't normally get the opportunity to talk through kind of platform, API, developer type conversations. I generally am up talking about speeds and feeds and networks and interoperability and things like that. But I get the opportunity to introduce an API now that we have for Link Server that allows Link to participate in software-defined networking architectures. And then after going through all that, which fundamentally is kind of a set of background to be able to understand what the heck does this actually all mean and what can we use it for? And luckily enough, this is a story that actually has utility for you if you have a Link deployment, if you're a partner and you're working with customers that have Link deployments. This actually is something that has value, and that not only we've been able to bring to the market, but with a lot of work from our partners have been able to bring to market. And so that's what we're doing today. Does that all sound like a valuable use of your time and that you're not expecting, I don't know, 400 level phone debugging stuff? Okay, good. Hey, there was one response from the audience. Yay! All right. So I have a buddy who works in a fairly sizable IT organization that has a big internet presence. If you have kids, you've probably seen one of their movies or been on one of their websites. And if you like sports, and that's all the hints that I could probably give you. But they had to move a data center. They had an old data center set up in the West in Seattle that they'd had for years and years and years, and it was getting kind of long in the tooth. And they're like, "Hey, let's move to Vegas where it's modern and clean, and there's power that doesn't go goofy and all this kind of great stuff." And I was having beers with him one night after going through a process of actually cleaning out down to kind of the bare rack of what it took to actually move this thing across, and it was just horrifying. When he was telling the stories of, hey, we'd spin up a service, and we'd think everything is clean and everything's running, and then we'd have this whole list of tests that we'd have to go through, and we'd have this window of about 5 hours between 11 and 4, 11 o'clock at night and 4 in the morning, that we'd be able to kind of do this work. And if we knew right around 3:30 or so, if everything wasn't redirecting in the right way, that we'd start to have to roll everything back. And then we had another period of time where you have to roll everything back and then, flip the switch again to have the soon-to-be turned-off data center still back handling traffic after they figured out that it didn't work. And it literally took them like 3 or 4 weekends of just, okay, we've got a plan, let's try it. Oh, that didn't work. Okay, let's go fix the plan. Okay, do it again. No, that didn't work. And it was a huge, pulling him away from his family for nearly a month. And what it came down to in talking with them is this idea that their network infrastructure that they had up and running just didn't allow for that flexibility. And I actually found I found one of these slides from our colleagues over in Windows Server. They're kind of talking about network function virtualization and kind of some of the issues that comes up with that. So if I go to add a VM into my stack, like what's the work that I've got to do to ensure that that VM is then available kind of across my infrastructure? And so here they're using the example of VLAN taggings, but this could apply to, whether it's DNS or whether it's VLANs or whatever. Like the idea is that as I need to make changes at the app level for my data center, having those changes occur down in the network level and making sure those happen in sync is really, really difficult and takes a ton of time. And the idea is that there's this opportunity to drive a lot more agility and a lot more flexibility by trying to break apart our apps and our kind of fundamental workloads in the data center from our networks. And so that's one of the kind of at the highest level. It's one of the problem spaces that software-defined networking is trying to address. And just a little bit of the kind of history of how we've got here. SDN started off as a kind of set of science projects at Stanford and Berkeley, where researchers were looking to figure out, are there some kind of new, interesting network protocols that we want to go and test. I want to test some different routing algorithms. I want to test some different back-off algorithms. I want to kind of go and mess with some very fundamental areas of the network. But I want to be able to do this in a way that, one, allows me to have kind of a good test environment and with some actual traffic, and two, not blow everything up. And so they came up with this concept of let's make changes to the network, and let's kind of have all those changes occur in software, so that way we can then kind of apply normal software methods to go and do testing, right? So I can go and I can create my kind of new protocol or my new instantiation. I can go and test that. I can see what happens. I can go and revert that. I can do that stuff really quick. That ultimately then evolved into a standard called OpenFlow. Has anybody heard of OpenFlow in this room? Yay! All right, about half. Cool. Okay, so that's kind of where OpenFlow came from. And then OpenFlow got picked up by the Open Networking Foundation and is now, in a lot of ways, has been kind of attributed as equivalent to software-defined networking. We'll break that apart a little bit. But this is incredibly useful for data centers at the cloud scale. So if you think about your Google, your Amazon, Facebook, Azures, where you need to have just giant racks and racks and racks of servers and VMs running on them, and you need to be able to move stuff around kind of at a whim or as needed in order to address scale, one. And two, they looked at this and they said, wow, if we can take all the elements of the network that require intelligence, we can put those into software, maybe we don't need to buy really fancy, expensive switches anymore. Maybe we could buy what are called merchant silicon switches that are, fairly inexpensive. And then we can rack those up into our data center and then just go and tell the switch what to do from a software perspective. And so when this started to really unfold, this concept of software-defined networking got encapsulated into really kind of three fundamental points. And I just completely stole this from the Open Networking Foundation. This is their words, right? So the first thing is, let's take the data plane, let's take the parts of the switch or the router that deals with moving packets from one port to another, and let's abstract that away from the control plane. Let's make these two fundamentally different things. And then bring all that control, all that network state, and all that intelligence, let's bring all that together, right? And then create a set of interfaces that abstracts all of that complexity away from my application, right? Those are the kind of the three fundamental tenets of SDN. SDN isn't open flow. SDN isn't cheap switches, right? This is really the fundamentals of what SDN means. I'm going to pull away my intelligence. I'm going to centralize all that together, and then I'm going to have a way for applications to interface with that intelligence. And so when you look at it from an open flow perspective, like here's my kind of vanilla switch in the center, and what open flow does, it says let's pull away that control piece, set up an interface between now a centralized controller and my switch with a little agent that runs on that switch, that then goes and tells the switch how to manipulate its fundamental packet management, packet flows, and set of flow tables. Fundamentally, we need this in the cloud scale. This is just something that is an absolute necessity, right? When we think about our cloud, when we think about the Azure Office 365, when we kind of consider what that means, it's a set of fundamental resources, whether that's storage, whether it's spindles and MIPS for processing and compute, or network services. There's just a whole set of fundamental resources that we want to then build up and apply through this term came from our colleagues in Azure, software-defined data center, that can then apply to all the different tenants and all the different applications and VMs that exist in our cloud. And we don't have the ability to do that. We don't have the ability to kind of just ad hoc randomly grab some spindle and some MIPS for processing and some networking without being able to have abstraction layers across all those three areas, right? So software-defined networking gives us the facility to provide that abstraction layer for the network. I am one of the marketing folks in the Link organization, so of course we've got to have the marketing slide with many numbers, and I'm happy to go and chew apart these numbers with you. For example, the global SDN market forecasting to grow at a CAGR of 62.3%. That is what we call in marketing the low denominator. It's so easy to have giant growth rates when you start from very small numbers. But regardless, you can look at these, you can look at other numbers. Regardless, there is a tremendous amount of fundamental investment that is happening in the networking space right now for SDN. It's happening across all of the traditional networking vendors, and it's providing an entry path for lots and lots of newcomers to come in and can very quickly build value. And it's the second point I want to make here is that it's not just at cloud scale anymore. Like that's absolutely where it started, right? With Facebook and Amazon and Google and Azure and all these big cloud providers, kind of looking at their networking infrastructure and saying there's got to be a better way. Now that's starting to move down. And it's starting to move down market into the enterprise in a very real way. And so a lot of what we're seeing here is networking vendors being able to bring SDN capable switches and equipment facility into their product lines that are applicable into the enterprise. But the quote that I love the most here is from Julie a little over a year ago, where she's really kind of takes the leap into, hey, what does this stuff really mean? Like, what's the kind of second order kind of derivative of value here? And that's the quote that I've got underlined, that applications will be able to dictate what they require from the network, what the network needs to do to support them. That's the insight that we have seen as well. And this is the reason that we are starting to chase software-defined networking specifically for Link. And so let me tell you why. Another way to reword Julie's message there is that we want applications and networks to play nicely with one another, play better together. And so we, as myself and my colleague Pascal, have done lots and lots of presentations about SDN, both internally and externally. The one key consistent factor across all those presentations is this adorable little child playing with a tablet, because it's just perfect. We need to have applications and networks play better together. I've had the pleasure of presenting the enterprise networking for Link session for a few years at a few different conferences. And so I stole the table on the left, where one of the ways to kind of organize the session is to do it off of the OSI layer. And for those of you that aren't familiar, the OSI stack is the kind of abstraction of a way to think about networks and the way the networks connect together. So, your physical and data link, being represented by Ethernet, network and transport layers. Generally, that's where TCP/IP fits in. Your session layer, session initiation protocol, or SIP, operates at the session layer, etc. And then I use that to draw rough analogies to different capabilities that exist in Link, things that you're going to want to configure, opportunities to have more management, more greater facility onto the network. And then I've kind of called out a whole bunch of scenarios and things you've got to think about at each of those layers. So if I'm going to go and deploy phones, maybe I want to have those phones deployed on a VLAN. Maybe I'm going to use LLDP so those phones can discover their networking capability and they can discover their location. We absolutely recommend that customers are marking media packets with DSCP to ensure that when the media packet hits the wire, if correctly configured at the router and the switches, that they're going to have optimal flows across your network. In order to ensure that those queues don't get overwhelmed with link traffic, then you need to set up call admission control and have an admission function that happens at the session layer that says, oh, if this queue at the network layer is too busy, then no, you should go a different path, or we're going to deny that call, etc. There's a lot that needs to be thought about and configured here for kind of the traditional how we do things today with link networking. The other piece that we've seen, in addition to this complexity, is that when we dive into the reasons why people have bad experiences with link, very, very commonly it's related to the network. And you could kind of argue about the percentage, and it's going to depend upon your customer deployment, if they're online, if they're on-prem, hosted. But generally, we see upwards of over 50% of issues of kind of poor quality of experience are attributable back to the network. First. Second, everything that you do in Link, of course, on signaling and in media is encrypted by default. That's good. It's good because, it's really, really hard to go and crack open that media. That's a good thing. It's, though, difficult to allow traffic engines, deep packet inspection engines, that sort of thing, to go and crack open the SDP and figure out what's going on inside. So that's on the Link side. On the Skype side, right? Skype has been designed for the last 10 years to try to actively hide itself from network administrators and just squirrel away and find random ports. And Skype is generally viewed as rather difficult to manage from a network admin perspective, right? I mean, that's going to a certain extent built into its DNA. And then from the previous slide, traffic engineering, setting up quality of service, all of those components that all need to line up kind of perfectly end to end, it's hard and it's easy to break. It's fairly brittle, right? And it requires static policy laid down onto the network that then when something goes sideways, oh, we had an issue with that one router. We found it was running the wrong firmware. So then we upgraded it. And when we upgraded it, oops, it just lost the fact that it needed to go and mark link traffic coming out of this port range for DSCP46. We missed it. Sorry. How do you go and find that? Well, you find it when somebody has, bad calls. My calls sound really, really goofy. Are you using the right headset? Is your laptop okay? Have you run Windows Update? You do all that client-side stuff. No, that's fine. Is it every call? No, it's just kind of random. I don't really know. Sometimes it's calls to the MCU. Sometimes it's peer-to-peer calls. you track it down, you track it down, you track it down, you find out, oh, it seems like it's every time calls go across this router, but it's not every time they go across the router. It's only at times when the router is overburdened that's dropping RTP traffic. It's very brittle in a lot of cases. And what we've found, of course, is that when users have a poor experience with Link, they don't accrue that poor experience to the network. Of course, they accrue it to Link. And they go, oh, this is a new phone thing you gave me. This is terrible. I can barely make a call on it. I don't understand. So we've got fundamentally, from kind of a deployment perspective, this is a risk. Like, we need to make sure that everybody has as best possible media experience with Link, kind of regardless, right? That's what's going on today. This is what I think about in the future. When we're standing up more and more tenants in Office 365, when I have got lots of partners that are doing hosted, Link server deployments, when there's more and more of this of Link deployments that are hybrid across those three different models, right? An on-premises model, a partner-hosted model, an Office 365 model, and there's traffic, signaling traffic, media traffic happening between all three of those. So there's that kind of complexity, and then there's just the pure complexity of scale, right? Where I imagine each one of these rows being a set of tenants in one of our data centers. So the bottom row is Singapore, and the row above that's Dublin, and then the giant thing up above that's North America. And how are we going to ensure great quality for all the people that are sitting inside of those cars, right? So this is first the problem space around that SDN was looking at. And then there's this problem space that we're looking at from a Link perspective of how can we ensure great quality. And so let's go back to this concept of applications programming networks. And we're going to start to break this down into the kind of fundamental both SDN architecture and then how Link is going to plug into that. And so there's fundamentally three tiers. At the top tier is the SDN application. Now, traditionally, this is a virtual machine or a virtual machine management type of application. So like this traditionally isn't viewed as an end user application. This is where SDN came from, right? I want to have some plasticity in my data center to be able to move around virtual machines and be able to make changes to the way that I'm servicing my tenants and my users in a really rapid way. But the abstraction here can really be any application, right? So I've got this concept of a set of applications, traditionally data center focused, talking through a northbound interface or a northbound API to a layer called the controller. And the controller is where we've centralized all of the network intelligence. And what the controller is going to do is it's going to take in requests from all of the different applications, and it's going to manage what applications get what resources when. And there's the centralized set of policy, and there's a centralized set of knowing the resources that are available in my network. And then using a southbound API, or in some cases, multiple southbound APIs, depending upon kind of how OpenFlow ends up working out, going and talking to the network elements. And OpenFlow is a southbound API. OpenFlow is where that southbound API, that's where OpenFlow fits in. Again, is the communication between my network elements, whether they be physical or virtual, so like virtual switches, physical switches, whatever, and my controller platform. And so my application says, hey, I need to make a change. I need to now go and run against a different set of virtual switches in a different data center. And the controller says, great, I know what to do for that. I'm going to then go and move those VLAN tags over from this set of switches to this other set of switches. Go ahead. And that's a fairly low-level set of work, right? But it's something that is abstracted away from the applications. The application doesn't have to manage those minute details. when we take this architecture and we go and apply it across to Link and Skype, you can imagine Link and Skype being that application communicating over a northbound interface to the SDN controller, telling that SDN controller, this is what we need in order to go and have great quality for my Link and Skype media flows. If you kind of break down that left-hand side, again, data center virtualization, the primary thing that folks in the SDN community talk about with respect to the utility of SDN. Unified communications is very rapidly kind of ending up being the number 2 on that. That SDN controller, fundamentally this kind of looks a lot like the Wi-Fi controller. If you're familiar with Aruba and Cisco and so forth, and the way that they manage things, where they've got a controller that then goes and talks down to all the different physical radios and manages the way that those radios operate with power, the way that the clients are connecting to all those different APs. And then the actual fundamental pieces of infrastructure, generally routers and switches, but could also include WAN optimization and application delivery controllers. Back at that marketing slide, Gartner's predicting this year 9 out of 10 network security vendors are going to be supporting OpenFlow. So there's going to be a lot of network infrastructure that's going to exist communicating at that southbound API up to the controller. Another way to then kind of break this down just a little bit further, and the reason I'm doing this is specifically with regard to some partner scenarios I'm going to talk about a little bit. Same idea at the top, right? I've got my end user application, Blink, Unified Communications, with a set of application-focused northbound interfaces, then going to a set of functions. We actually see the controller, in a sense, kind of splitting into 2 sets of apps. One set of apps kind of appropriate for the kind of high level, what the controller is talking to. So, whether it's intrusion detection, network security, unified communications, quality of service, whatever the case may be, kind of having those split up, and then talking down through another set of northbound interfaces into kind of the lower level control and management functions. Updating my stats, updating my flows, taking inventory of all my network elements, and then using OpenFlow or a similar southbound interface to go and talk to the fundamental network elements here. And whether the controller is just that layer, or whether that controller actually includes some kind of higher order network services, you can operate in kind of both paths, right? And to a certain extent, these things are loosely coupled. You may hear the concept of northbound interface latitudes, and that's what this is describing. So as SDN kind of kicked off, everyone was really excited about OpenFlow and the southbound side, and like, hey, we're going to go and tell switches what the heck to do, and this is great. And then when we started looking at the northbound side, we realized, wow, there is some levels of complexity here that we want to be sensitive to, and that maybe we want to provide some differentiation for the application. And in some cases, the application is going to talk to these network services. And in some cases, maybe the application will want to talk down through those red arrows into the lower level kind of control and management standpoint. So that's the concept of northbound API latitudes that you may hear about as you go to investigate this a little bit further. So what the heck's Link doing with all this stuff? Not surprisingly, Link has, based on our little description here, Link has a northbound API. So Link has an API that is designed to go and interface with a network controller and go and tell that network controller what to do. And this is the architecture that I stole straight away out of the documentation. And it does a fairly decent job. What you'll see on the right-hand side there that SDN XML, that's the northbound interface. That's the interface of link talking to the network controller. Now, when I say link, I've kind of abstracted out a little bit. Of course, we've got some detail in this as well. And there's kind of three fundamental parts that are reflected in this picture. The first are, on the far left, the two link clients communicating with one another. So they're in a peer-to-peer call. They're exchanging media, right? At the instantiation of that call and at the end of that call, they're sending some information up to the front ends, the pool that's there in the center. Each of those front ends has a component running on it called the Link Dialog Listener. It's acronymed LDL here. And what the Link Dialog Listener is doing is it's going through and it's capturing all the events that are pertinent to the SDN model, right? So when does call fire up? When are we getting some QoE data? And it's collecting all of that data and then sending that over to the SDN manager over on the right. So the idea is that we don't want to have a fire hose of information going to our network controller. We want to try to aggregate together information about sessions. We want to aggregate together some content and then provide that over to the controller. So the concept of this dialog listener that's sucking data off of the front ends and it's pulling QoE data and then shuffling that off to the SDN manager and then having the SDN manager go and transport that in one kind of jump over to the network controller. This gives us this kind of model here is a slightly different view, saying the same thing. Link client goes and talks to the FE. The FE has this component, this dialog listener component that's going and cranking across data, sends that to the SDN manager. Should that SDN manager fail, then we have a secondary SDN manager that can run. This is all software, so this can run in a VM. This could run off-board, whatever the case may be. And then that SDN manager then goes and fires off to any number of network controllers that you have in your environment the information that we've collected about that particular session. So a little bit on kind of configuration and installation. First, if you have a Link server, you can go and download this today. It's available. The SDN API is available for free. So you can go and check it out. Check out all the documentation. You can crack open the XML and kind of see what we're sending and everything else. So fire up a VM, drop in .NET 4.5, and then install this on the top. There's fairly simple sets of configuration to do here on the SDN manager. Basically, we just need to point it to the URIs for the network controller that the network controller is going to pick up information from. If you need to make any changes after the initial install, there's a config file that you can then go and edit. You can tell that we had done the development work on the SDN API out of sequence from the main line of Link server, right? So it's not PowerShell integrated as in the topology builder and everything else. This is an add-on component that you're putting onto Link server. And the dialog listener is installed on all the front ends in your installation. It's a pretty lightweight process. We've done testing. We've taken this up to some scale, so we feel pretty comfortable about this. You then go and point the dialog listener to the SDN manager. Again, you can have a bunch of different SDN managers for failover. And the dialog listener is where you provide some configuration to this. So not just kind of where you want to shoot this data off to, but I imagine the conversation that came across for the second parameter there, hide PII. I can imagine the customer saying, "So you're going to have an out-of-band way to give all call information over a web interface, and that's interesting. That's going to that's going to have a lot of detail in it, isn't it? Well, yeah, it's going to have, phone numbers and URIs and call duration and quality and network location. So we'd be able to pinpoint exactly where, with the 5 tuple, we'll know exactly where that person is. And yeah, so by default, you should hide all that, right? And so the hide PII, turn that on to where all the PII that gets sent across is all obfuscated. And then actually in the SDN manager configuration file, or in the SDN manager directory, there's a tool there called SIP obfuscator that if you need to go and back out and actually find the find the PII for a particular record, you can run the SIP obfuscator, and that'll go and that'll give you the GUID that we end up replacing when you're hiding PII. Couple other parameters in terms of how much information you want to send across the interface. You can send the raw SDP if the party on the other side finds some utility for that. If you want to send all the QoE records or just the ones that are associated with bad calls, that sort of thing. And this is kind of what the flow looks like, right? So SIP messages between the link client and the FE. Dialog listener is picking that up, sending that off to the SDN manager. This does give us a level of abstraction, right? And so we have the opportunity to do some kind of differences and kind of iterate on the API between the dialog listener and the SDN manager. You guys are in a position you don't have to worry about that signaling and that traffic. So that gives us a little bit of flexibility. But on the SDN API front, what's coming out of the SDN manager, that's where we want to be really clean and have a really defined interface that has backward compatibility. And ultimately, this interface has been submitted to the standards bodies as well for ultimate ratification as the UC northbound interface. And we'll talk about the standard stuff in a little bit. But just a kind of a quick view of the methods. So we'll tell you when an invite happens. We'll see when there's a media session that starts up. If that media session changes, we'll send an update. So if codecs change or if the endpoints that are involved in this particular session change, and we can send an update. Something bad happens. And then after the QoE report gets sent from the client, remember, after you end any link call, you end that call, the conversation window goes away, we package up all the information that we have about the media session of the call, we package up, what endpoints you were using, what the error rates were, what your network information is. We package all that up. We send that up to the QoE server. The dialog listener then grabs that and can shuffle that off to the network controller as well. So essentially, kind of saying the same thing, but with a slightly expanded view here. So I've got a call between two endpoints. My signaling, obviously, is going through the FE, but my media is going direct between these two endpoints. And it's traversing a whole series of different network elements, right? Maybe one of those clients is on wireless. I'm going through WAN optimization. I've got firewall rules going on here because one of them's internal, one of them's external. Obviously, my kind of core switches and routers and so forth. And so when I send that initial hey, there's a session that started up, I'm going to give a whole bunch of information about that dialogue, and this is the set of dialogue related events, right? So what media am I using? What are my codecs? I want to see my transport. I want to see the source and destination ports, the IP addressing information. My SIP URIs that are involved, obfuscated if you have that parameter set, and any kind of unique call IDs. So that gets sent to the network controller, and the network controller then has the opportunity to use that southbound interface to go and influence the way in which this call is managed, right? So now the network knows, hey, this kind of random flow of traffic that's happening on my network right now, I actually know something about it. It is unique, and it is something that I care about because it is link traffic. It is not YouTube traffic. It is not ESPN traffic. It is traffic that needs to be treated differently and uniquely in my network. And this kind of, in essence, out-of-band signaling in a standards-based way down to the network gives us lots and lots of power. It gives us lots and lots of capability. So that's the event for when a dialogue starts up. Then after the call, let's say that I want to send all my bad call QoE information up to the network controller. Something bad happens, between a couple switches. So we're going to send my quality update event. I'm going to send up my 5-tuple. I'm going to send up my NMOS. I'm going to send up my calculations of jitter and delay and packet loss and all these other elements. And similarly, then the network controller has the ability to go and take advantage of that information. So we'll see when we start talking about the scenarios and the use cases for this API, how some of our different partners are taking advantage of this content. We are not done developing. We have only just begun. And right now, the API is the 2.0 release. And so we've got to working with a bunch of customers. We've got to working with a bunch of partners. And so now we're getting all the feature requests in. This is great. So generally, looking at the second half of this calendar year, we're gonna turn the crank again and have another update come out. One of the things you may have noticed is that we're going to send some information at the beginning of the call. We're going to send some information, some QoE information at the end of the call. Right now, the client doesn't send anything in the middle of the call. And so we'd like to establish a pipeline from the clients and MCUs through the FE for mid-call updates as well. And this has been one of the big requests from partners of like, hey, you guys are tracking, remember, with RTCP, every 5 seconds we send out an RTCP packet and we say, hey, what's the network like? Hey, what's the network like? And that's what powers the little signal indicator in the link client, right? And so we know if things start to go sideways, we've got that information in the client. Let's push that information up through this pipeline and let's get it in the hands of the network controller, because then the network controller maybe can do something with it. That's the first piece. Second, love to be able to have this architecture integrated, more fully within the pool, right? Right now the dialogue listener is functioning within the FEs. It makes tons of sense to have this kind of be more integrated in with the FE fabric, so to speak. Having the SDN managers today, there's a kind of primary and a redundant or a primary secondary type of organization for the SDN manager. Love to be able to have those with a shared database state and to be able to have them flip over back and forth. And then the link dialogue listeners, where a bunch of the configuration is stored, you'll notice. So like the hide PII and those kind of pieces, those are all functions of the element that's sitting on the FE, and that's scooping data out of the FE. That we can make easier to have kind of centralized and simplified configuration of that. And there's some computation that is still happening on that link dialogue listener. And generally, we'd like to save things that take up MIPS. We like to save those for resources that are not running on the FE, because the FE is busy enough as it is between response group service and AVMCU and, oh yeah, managing your presence updates. So we like to pull as much of the kind of intelligence off of the FE and have those run at the SDN manager. So we're looking to make sure that the kind of balance of trade, as it were, between those two components makes the most sense. So there's still a bunch of work that we're doing on this. In addition to the work we're doing inside the building, we're also doing a bunch of work in the standards bodies as well. And there's two primary standards bodies that we're engaged with, and you'll see my colleagues, involved in the technical working groups of both of these. First is the Open Networking Foundation. They're the ones that are kind of shepherding SDN generally and OpenFlow as well. They've created a northbound interface working group. So there's a working group that's specifically thinking about this northbound interface, and they've split up into into 3 different task groups, one of which is specifically focused on end user applications. And so that's the kind of admission by the Open Networking Foundation that, hey, this makes a ton of sense to, let's just not think about kind of networking, cloud, data center type stuff. Let's not think exclusively around kind of API architecture, latitude stuff. Let's also pay attention to the utility that SDN can provide for end user applications. Their mission, drive adoption and by lowering barriers to folks to deploy and to write SDN-enabled applications. They have a liaison in the end user applications task group. They have a liaison to the UCI forum, right? This makes sense because the Open Networking Foundation, they don't play in UC. Like, they're not necessarily UC experts. And so the idea is, let's take the use cases and the kind of UC-specific knowledge that exists within the UC Interoperability Forum. Let's write down the scenarios and figure out what the test harness looks like, and let's get all the kind of very specific UC stuff, and let's be able to bring that into the Open Networking Foundation. So there are ones. The UCI forum is figuring out the scenarios, figuring out the use cases, and then ultimately responsible for the certification kind of interoperability programs that will come out of having a standardized UC SDN interface. Again, Microsoft has volunteered, hey, we've got one. We think that it may have some good stuff in it. Let's start with ours. And then within these standards bodies, folks will start adding to that and arguing over it and doing all the good work across the industry to go and have a kind of single interface here for not just Link, but for all the other UC applications out there to find a way to talk to not just one network, but all the networks that are out there that subscribe to an SDN architecture. So this really is how this is going to scale beyond just Link and beyond just Microsoft. And this is really important work. Unfortunately, as with anything across standards bodies, this is also work that takes effort and time. So this isn't something that I'll be here next year at the at TechEd saying, look, here, it's done. But we are accountable to report back progress, not only to these foundations, but also to our bosses. So we've talked about what SDN is and kind of what it's used for in cloud stuff. And we've talked about the nature of Link and packet networks, and then what we've done, which is this SDN API that takes a bunch of information about what's happening in Link media flows and shoots it down an XML-based path, a bunch of events and a bunch of data. Now, what the hell do you use it for, right? So we pretty early on said we can't just do an API. We've got to really focus it around what matters, right? And we can't just talk about SDN as a strategy and have a bunch of architecture slides. As much as you may think that marketers love to do that, it really does suck. We really do want to have something that has value, and so these are the 3 kind of fundamental scenarios that we're starting with. This doesn't necessarily mean this is the only place where the SDN API or UC SDN generally is going to have utility. We think these are some pretty important things to go and address. And no big surprise from our problem statement that diagnostics ends up being pretty early on in this list, right? How do we correlate and how do we diagnose what happens when there are link issues that are kind of poor quality? How do we correlate those to network effects? That's a really difficult thing to do. And so this is one of the first use cases that we came out with. In fact, very early on when we were talking about this API and kind of figuring out its utility, this is the only one. And so we really kind of talked about it as a diagnostics API or a network diagnostics kind of function. And what we've done with each of these scenarios, is partner with a small number of vendors who are really good in this space. And so who's really good in the kind of network diagnostic space? One of those companies is Nectar. And so what Nectar does is they're all about having a really robust correlation engine. And so what they'll do is they'll correlate between a whole bunch of different data elements, right? So they'll correlate between link infrastructure, between other UC products and endpoints. They'll take information off of the wired and wireless infrastructure. They also talk to a whole bunch of gateways and SBCs and other types of kind of voice infrastructure that exists in link networks. And they work to bring all that together in a kind of single platform, right? And so what they're providing here for end users is a real-time way to have link flow information, link quality information correlated with what's going on the network. Another kind of view of this, one of the things that gets really compelling, first, not only are they able to pull kind of raw RTP content off of other UC systems. So they do a bunch of work with Cisco, they do a bunch of work with Avaya, and they're able to pull in, you know, the kind of fundamental network and RTP data. In addition to they'll pull in skinny data, they'll pull in 323, they'll pull in SIP data, and then they'll also have probes sitting out on the network, and those probes are getting routing information off of the switches, hubs, and routers that are across the network. And so they can have a kind of a topology view as well that is fairly unique that we found in the industry. So they're able to, off of the router, look at fundamental packet loss. They're able to look at kind of hop by hop. Oh, I've got a set RTP here and a set RTP here, and there's a delta. What's going on? And then they can match that up with what they're getting off of the SDN API. So the Nectar management platform is an SDN controller. It's one of the kind of instantiations of this, and they're really kind of doing it to pull a bunch of data in. SDN is one of those interfaces. And so by bringing all of this information together, by bringing together what's fundamentally happening on the wire and the network, plus the stuff that's going on from Link, from the SDN API, plus what they're picking up from other PBXs and UC systems, they really do provide a pretty intense end-to-end view of the user experience. And so they're able to take these kind of really rough correlation type issues. I have a bad call and I have some traffic on the network, and what was going on at that particular time to be able to bring those two things together. And on the on the kind of probe front, this is fundamentally one of the pieces that we think is most interesting, because fundamentally we're not coming out with a message to the market and to the general industry of you need to retool your network end to end in order to take advantage of SDN. That is not the message at all, and unfortunately in some cases it gets kind of perverted that way, and I think there's some competitive aspects to that which get really interesting. The idea is that you can use the interface, and our partners are also using some of their own kind of hard work of sitting on the spanning ports of switches and routers and tumbling through a whole bunch of this data and then correlating it with the Link SDN API to come up with some insights around what's going on. So Nectar is our first partner in this diagnostics front. This diagnostics scenario, though, has a whole list of partners who are right behind it, right? So we worked with Nectar so they could go and tell us stuff like, maybe it makes sense to obfuscate some of the data that you're sending off here. Maybe you should think about, a different kind of data format or a cadence that's going to make a little bit more sense for this diagnostic scenario. So we worked really deeply with them in kind of the early versions of the API, and now we've been able to open up this segment of the SDN partner program for other players to come in. And I want to say there's somewhere in the neighborhood of just on the diagnostics front alone, it's very popular. There's a good 6 to 8 other partners who are actively working on solutions, and that, as I know, is something that at the next Tech Ed we'll be able to talk about a lot more. We'll have a lot more demonstrations of what that actually of what that means and how those solutions are different. So that's the kind of first big thing that we want to go and figure out. Let's try to solve the complexity around link media and trying to diagnose and troubleshoot it on the network. Second big thing that we want to go and address is this quaz issue, right? And I kind of glanced over it a little bit earlier, where I had the 7-layer bean dip stack of the OSI, and I was kind of talking through all those different pieces. But it ends up that even just doing quaz, even just kind of taking that first step and saying, yeah, we're going to go and mark all the link traffic. This will be great. It is necessary, and in a lot of networks, you absolutely need to do it. But it is a significant amount of work, right? And so we just kind of talked to some customers, and we wanted to break down. All right, between the UC admin and the network admin, like, what do they need to do in order to, from the point that they decide we're going to enable DSCP for all of our endpoints? What does that mean? Well, let's figure out what kind of traffic all these endpoints are pushing, because I've got some endpoints that can push some really high bandwidth, high bit rate stuff. I can do HD video. I can be screen sharing a 1920 size monitor that's running a video, or that's flipping through PowerPoint presentations pretty quick. I got people running around with mobile devices that can do audio and video and that can receive desktop sharing. I've got people with phones that are plugged in. I've got people with phones that are undecked. I've got all these different classes of devices. Then I've got to decide, well, am I going to mark all my traffic on my endpoint, or am I going to mark all my traffic on the router? I've got some network admins that I talk to who are investigating this, who absolutely, positively don't trust a laptop any further than they could throw it, right? They go, well, no, I'm not going to mark packets on the laptop. Are you kidding? Someone who's smart out there is going to go and figure out that I'm honoring DSCP 46, and they're start marking all their BitTorrent traffic with 46. And that's terrible, and that'll bring down my network. Well, if you're not running Active Directory and you're not pushing that down through policy, yeah, I guess that's possible. But fine, that's okay. We know you're good. Don't trust the workstation. That's fine. Okay, so then we've got to decide what ports you're going to listen to. So we'll nail up a link and say media is only coming out of this port range, and so then the router sees the traffic coming from that port range of the source and goes, oh, great, I know this traffic's coming from port 5000, and it's UDP, and I know that means that it's link media traffic, it's video, so I'm going to tag it with this DSCP marking audio. I'm going to tag it differently, so it's on separate port ranges. But that goes on and on, right? Okay, well then we've got to think about the servers too, and we got to think about the clients, and well, what codecs are you using? Let's run the Erlang numbers. Let's make sure that we're not going to overflow on this, or if we do overflow, it's only at the 0.001% of overflow, that sort of thing, right? And then maybe you're actually ready to roll out. It takes a while to do this process, and not only is it sophisticated, it is also brittle. And so working with HP, they don't just provide the workstations that are out in the hallways for you to submit your evaluations, which are very important, by the way. They also, of course, have a networking division, switches, hubs, routers, and they're very, very engaged in SDN. And so their concept is, well, okay, you're going to go and tell us that there's a media session happening. And so I've got two clients. They're both going to be talking to one another. You're going to send me this dialogue start event saying that something's going on. And so now what we're going to do is we're going to pick that up, this HP UC&C SDN application. They just announced this at Interop a couple months ago, or maybe even last month. And this is that concept I was talking about the latitudes of the API, right? So they have an application. That application then talks to their controller through another northbound interface. But they have those two elements, right, logically separated, but existing within the same kind of physical architecture. So they get the dialog information in their application then sends that down to the controller, and the controller then says to their switches, here's the information that you need to go and prioritize this traffic. Instead of the kind of brute force, make sure everything is tagged in just the right way across all these different network elements, and doing that from the beginning, right? We can do this at instantiation. We can do this at the instantiation of the media event. The other thing that's cool is that, and again to the point of you don't have to go and rip out all of your existing infrastructure. Imagine this topology, right? So I've got two branches, and they're connected by a kind of core, and that core I haven't upgraded. The core doesn't know SDN, right? But I've got some switches that are running out in the branch that do run SDN, do understand it, right? And so the idea is that they can actually, at those kind of edge devices, they can use SDN to then tag that traffic appropriately so that it goes through their core at the right level of priority. So again here, get a dialog start event. Their controller then goes down to those two switches that are running in the branch saying, hey, there's a call that started up between these two endpoints. Now what happens is when the media traffic goes and hits that initial kind of hybrid open flow, as they've termed it here, switch, we're not tagging any traffic to go to that branch router, right? It's in the branch. It's probably right over there in the closet. I don't need to tag any traffic to go over to the closet. But when I do go through the WAN, through the core, down to the other branch, that's where it needs to be tagged. And so in this case, here HP is saying, let's tag that for the purposes of transiting the core and the aggregation layers with the right level of facility. All right? So now, again here, this concept is that the network is effectively link aware, right? Even though they haven't gone through and switched out every switch, hub, and router in their enterprise network. Of course, it'd be ridiculous to try to do so. They didn't need to. All they needed to do was have OpenFlow enabled switches that are running in the branch that then take advantage of the kind of, in this case, potentially legacy core and aggregation layers that traffic needs to transit. So this is an interesting take on kind of a hybrid SDN model where you can take advantage of both the new world of SDN switches in addition to what you already have in your enterprise. Fantastic concept from HP. And then Aruba, our third partner. HP's stuff, just to wrap up on them, HP stuff announced very, very shortly to be available. They've got millions of ports of OpenFlow enabled switches. First of all, if you have an HP network, I almost guarantee that your ports are OpenFlow enabled, so you're already good there, right? Their controller and the application that runs on that controller to go and interface with Link, that's what was just announced. That is what is coming soon. Okay, Aruba. Aruba, kind of consummate overachievers they are. They wouldn't settle for just doing diagnostics or just doing quaz. They're doing both, right? So Aruba says, hey, there's a lot of utility for us to be able to understand at the AP level, on the air, what percentage of airtime is being taken up through different parts of traffic. And we'd like to uniquely identify the link traffic that's running over our air. So there's a set of kind of diagnostics there that they're operating on. And then at the same time, they want to be able to provide quaz, not just over the air, but when they terminate that over-the-air traffic onto the wire, right, they want to be able to make sure that hits the wire with the right level of priority. So that way, when you're transiting over the air, that's not DSCP. DSCP doesn't exist in 802.11. It does exist though in our standard IP networking, right? So they've got to take the WMM values that exist over the air and they got to throw those down onto the wire. So they're doing both scenarios with their firmware and their architecture. So again, kind of the same sort of path. SDN manager says, hey, we're in call. We've got a call going on. Great. We're going to make sure that traffic gets appropriately shaped and if necessary retagged. Let me just build this out. And they're able to then also do a lot of their kind of more sophisticated RF management stuff in coordination with this as well. So they can be able to do things to say, oh, I get that you're a radio that's on both a 2.4 and a 5 gigahertz band. I can make sure to roll you up to the 5 gigahertz band, put you at a slightly different radio, and take the folks that are on that radio that could be a little bit further away and move them off to another radio. And they can have that kind of adaptive traffic management. They can be smarter about that if they're smarter about what flows are happening through their network. And we're giving them that information through the SDN API. So this is available today through Aruba. They are actively, if you have Aruba gear that's running your radios, that's running your Wi-Fi, call them up and ask for the upgrade to that infrastructure, because it is transformative in what they can do to actively prioritize, not only actively prioritize the traffic that's going over the air, but also to be able to actively report and monitor and provide diagnostics on the link media traffic that's going through the air as well. Just a little bit of kind of more information on the same concept. So, and finally, orchestration. I don't have any partners yet that have taken on the orchestration bit. This is the concept of all of the network elements, not just radios for Wi-Fi, not just network management systems, not just switches, hubs, and routers for QoS, but all the network elements that are necessary for a link media flow to all be listening for an SDN message and all configure themselves at real time for that particular traffic flow. And so you can imagine your intrusion detection, your application delivery controller, aka hardware load balancer, your firewall, all of the elements, all the network elements, your reverse proxies, right? All the things that need to be in kind of perfect concert, that all need to be configured correctly, that all at some point have some configuration drift. All of those elements of the network eventually are going to be SDN enabled. And so the concept behind orchestration is just as it sounds. Let's orchestrate all of those individual elements at real time for when a session or when a flow starts up. This is what gets my service operation engineers in Office 365, I shouldn't say our service operation engineers in Office 365, very, very excited, right? Because there's human error everywhere. How many times have we been banging our heads against the wall because, I've got this one particular link media, path through Edge, over mobile, et cetera, it doesn't work, and I can't figure it out, and it's because I transposed 2 letters, and it's 3 in the morning, and so blurry, I can't see it in the PowerShell, right? Like, that stuff happens, it's very real. And the concept behind orchestration is that level of detail and that level of facility that's necessary in order to make those things happen isn't necessarily required. Then we can have all the adjacencies to link should be able to listen to link in a secure, out-of-band fashion and say, yep, this is absolutely what we need to do. We need to go in and enable this enable this port through the firewall, turn off my intrusion detection system because I know this is traffic that I'm already kind of aware of. I'm going to make sure that my load balancer is correctly assigning that traffic to the right AP or to the right front end, and all of the quaz stuff happens, and all the radio stuff happens on the AP, right? So that's where we're going with this. That's our kind of vision, and to have that exist across both server and service and hybrid deployments. That's fundamentally where we want to take this capability. And so with that, we talked about SDN at the kind of high 50,000 foot kind of meaningless level, and then actually how it applies to Link, because Link and packet networking, we spent a lot of time on it. And we spent a lot of time on it at Link Conference. We spent a lot of pages on it. There's a 400-page Link Enterprise Networking Guide that if you're into Link and networks and you don't have that on your workstation, you need to download it today. And there's a lot of opportunity for us to do better. And SDN is a set of technologies and a whole industry trend that is just super exciting and super interesting. Again, very nascent, lots of changes that are happening in this space, but it's a place that we're really excited to play in, and excited to kind of help lead the industry and say, this data center VM moving around thing is great. That's probably solves a bunch of big problems, but real-time media and traffic, there's a bunch of stuff here that we can do better. And so thank you so much with that. If you have any questions, love to hear them. If you feel brave, there are microphones here, and then the people that are listening to this asynchronously would also benefit from your question as well. If not, then I will sign off. And thank you so much for your tech ed. Please, 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 please send in evaluations, not just for this session, for all the sessions. We really do read them and we care about them. And if every other speaker, if you ask them, I promise you they will say, yes, this is something that we care passionately about. And if they don't, tell me, because I will find them and hunt them down. But please take some time. Tell us what you think about not only the conference, not only the tracks in the office group, but also the session. Thank you so much. Flexibility by trying to break apart our apps and our kind of fundamental workloads in the data center from our networks. And so that's one of the kind of at the highest level. It's one of the problem spaces that software-defined networking is trying to address. And just a little bit of the kind of history of how we've got here. SDN started off as a kind of set of science projects at Stanford and Berkeley, where researchers were looking to figure out, are there some kind of new, interesting network protocols that we want to go and test. I want to test some different routing algorithms. I want to test some different back-off algorithms. I want to kind of go and mess with some very fundamental areas of the network. But I want to be able to do this in a way that, one, allows me to have kind of a good test environment and with some actual traffic, and two, not blow everything up. And so they came up with this concept of let's make changes to the network, and let's kind of have all those changes occur in software, so that way we can then kind of apply normal software methods to go and do testing, right? So I can go and I can create my kind of new protocol or my new instantiation. I can go and test that. I can see what happens. I can go and revert that. I can do that stuff really quick. That ultimately then evolved into a standard called OpenFlow. Has anybody heard of OpenFlow in this room? Yay! All right, about half. Cool. Okay, so that's kind of where OpenFlow came from. And then OpenFlow got picked up by the Open Networking Foundation, and is now, in a lot of ways, has been kind of attributed as equivalent to software-defined networking. We'll break that apart a little bit. But this is incredibly useful for data centers at the cloud scale. So if you think about your Google, your Amazon, Facebook, Azures, where you need to have just giant racks and racks and racks of servers and VMs running on them, and you need to be able to move stuff around kind of at a whim or as needed in order to address scale, one. And two, they looked at this and they said, wow, if we can take all the elements of the network that require intelligence, we can put those into software, maybe we don't need to buy really fancy, expensive switches anymore. Maybe we could buy what are called merchant silicon switches, switches that are, fairly inexpensive. And then we can rack those up into our data center and then just go and tell the switch what to do from a software perspective. And so when this started to really unfold, this concept of software-defined networking got encapsulated into really kind of three fundamental points. And I just completely stole this from the Open Networking Foundation. This is their words, right? So the first thing is, let's take the data plane, let's take the parts of the switch or the router that deals with moving packets from one port to another, and let's abstract that away from the control plane. Let's make these two fundamentally different things. And then bring all that control, all that network state, and all that intelligence, let's bring all that together, right? And then create a set of interfaces that abstracts all of that complexity away from my application, right? Those are the kind of the three fundamental tenets of SDN. SDN isn't open flow. SDN isn't cheap switches, right? This is really the fundamentals of what SDN means. In the morning, that we'd be able to kind of do this work, and if we knew right around 3:30 or so, if everything wasn't redirecting in the right way, that we'd start to have to roll everything back, and then we had another period of time where you have to roll everything back, and then flip the switch again to have the soon-to-be turned-off data center still back handling traffic after they figured out that it didn't work. And it literally took them like 3 or 4 weekends of just, okay, we've got a plan, let's try it. Oh, that didn't work. Okay, let's go fix the plan. Okay, do it again. No, that didn't work. And it was a huge, like, pulling him away from his family for nearly a month. And what it came down to in talking with them is this idea that their network infrastructure that they had up and running just didn't allow for that flexibility. And I actually found I found one of these slides from our colleagues over in Windows Server. They're kind of talking about network function virtualization and kind of some of the issues that comes up with that. So if I go to add a VM into my stack, like, what's the work that I've got to do to ensure that VM is then available kind of across my infrastructure? And so here they're using the example of VLAN taggings, but this could apply to whether it's DNS or whether it's VLANs or whatever. Like, the idea is that as I need to make changes at the app level for my data center, having those changes occur down in the network level and making sure those happen in sync is really, really difficult and takes a ton of time. And the idea is that there's this opportunity to drive a lot more agility and a lot more, the heck does this actually all mean, and what can we use it for? And luckily enough, this is a story that actually has utility for you if you have a link deployment, if you're a partner and you're working with customers that have link deployments. This actually is something that has value. And that not only we've been able to bring to the market, but with a lot of work from our partners have been able to bring to market. And so that's what we're doing today. Does that all sound like a valuable use of your time and that you're not expecting, I don't know, 400 level phone debugging stuff? Okay, good. Hey, there was one response from the audience. Yay. All right. So I have a buddy who works in a fairly sizable IT organization that has a big internet presence. If you have kids, you've probably seen one of their movies or been on one of their websites, and if you like sports, and that's all the hints that I could probably give you. But they had to move a data center. They had an old data center set up in the West in Seattle that they'd had for years and years and years, and it was getting kind of long in the tooth. And they're like, hey, we should let's move to Vegas where it's modern and clean and there's, power that doesn't go goofy and all this kind of great stuff. And I was having beers with him one night after after going through a process of actually cleaning out down to kind of the bare rack of what it took to actually move this thing across, and it was just horrifying. When he was telling the stories of, hey, we'd spin up a service and we'd think everything is clean and everything's running, and then we'd have this whole list of tests that we'd have to go through, and we'd have this window of about 5 hours between 11 and 4, 11 o'clock at night and 4. Thanks everybody for coming. My name is Jamie Stark. I look after voice interoperability and networking for Microsoft Link, and it's my pleasure to bring to you your OFC B343, that's just rolls right off the tongue, session here at TechEd on software-defined networking. A overview for unified communications is the extended subtitle that we weren't able to fit in the non-metro style box there that accompanies our title. And what we're going to do, if the clicker does the clicky thing, is this is a really kind of fun session for me because one, this is just a nascent space a little bit, and so we get to talk about some technology that is new and different and kind of compelling. And so we're gonna start off with a little bit of a primer on what software-defined networking is for those of you that aren't steeped in cloud and enterprise kind of networking, latest best practices or latest stuff that's happening in the industry. And then we're going to look at how this applies specifically to Microsoft Link and how we think about Link and putting packets down onto the wire with a level of efficiency. And then from there, one of the other reasons why this is fun is I don't normally get the opportunity to talk through kind of platform, API, developer type conversations. I generally am up talking about speeds and feeds and networks and interoperability and things like that. But I get the opportunity to introduce an API now that we have for Link Server that allows Link to participate in software-defined networking architectures. And then after going through all that, which fundamentally is kind of a set of background to be able to understand what